Have you ever wondered how geologists study the Earth? It's not just about digging up fossils and collecting colourful stones. Sometimes we need to break rocks down to their tiniest particles. And no, we don't always need a hammer for that. Some powerful liquids can do the job too. Imagine a drop of liquid eating its way through solid rock. It sounds like something out of a science fiction movie, right? But it's real. This is the power of chemistry at work, helping us unlock Earth's secrets one rock at a time. These liquids, whether acidic, alkaline, or something else entirely, each have their own unique ways of breaking down rocks. Understanding how they work is like having a superpower, the ability to decode Earth's history. So buckle up as we go on an exciting adventure into the world of rocks and the amazing liquids that break them apart. Acids are like tiny etching tools, slowly dissolving certain types of rocks. One of the most common acids used by geologists is hydrochloric acid. It's great at dissolving carbonate rocks like limestone. Remember the fizz when you drop vinegar, which also contains acid, on baking soda? It's the same reaction, just on a larger scale. Sulfuric acid is another powerful acid used by geologists. It's especially good at breaking down rocks containing metals. This acid is a bit more heavy-duty, like using a power drill instead of a hand drill. Then there's nitric acid, which is used to dissolve rocks that contain gold or platinum. These acids help us understand what these rocks are made of and how they were formed. It's like using a chemical key to unlock a treasure chest of information. But acids aren't the only liquids that can break down rocks. Alkaline solutions like sodium hydroxide and potassium hydroxide are great at dissolving silicate rocks. These are rocks that contain a lot of silica, one of the most common minerals on Earth. Think of alkaline solutions as the opposite of acids. They work in a different way, but can be just as effective at breaking down rocks. It's like using a different tool for a different job, depending on the type of rock you're dealing with. These solutions are particularly useful for studying volcanic rocks, which are often rich in silicate minerals. By dissolving these rocks, geologists can analyze their chemical makeup and learn about the processes that formed them. It's like piecing together a puzzle, one dissolved rock at a time. Section 4. Chelating agents, a chemical embrace. Now let's talk about chelating agents. These are special molecules that can grab onto metal ions in rocks and pull them out, effectively dissolving the rock. It's like a chemical embrace, where the chelating agent wraps around the metal ions and carries them away. One of the most common chelating agents used in geology is EDT, or ethylene-diaminotetracetic acid. That's a mouthful, right? Don't worry too much about the name, just remember that it's really good at grabbing onto metal ions. ETA is particularly useful for dissolving rocks that are rich in iron or manganese. It's like using a magnet to pull out iron filings from a pile of sand. This helps us understand the distribution of metals in the Earth's crust and how they've moved over millions of years. Section 5. Oxidizing agents, rusting the past. Finally, there are oxidizing agents like hydrogen peroxide. These work by adding oxygen to the minerals in rocks, causing them to break down. Think of it like rusting, but on a much faster and more controlled scale. Oxidizing agents are useful for studying rocks that have been exposed to weathering and erosion. By speeding up the natural process of oxidation, geologists can study how rocks break down over time and how this affects the landscape. It's like fast-forwarding through millions of years of geological history. So there you have it, a glimpse into the fascinating world of breaking rocks with chemical liquids. These liquids are essential tools for geologists, helping us to understand the Earth's composition, history, and the processes that shape our planet. It's like having a secret language to communicate with the Earth and uncover its hidden stories.